Hi there, folks. Today we're looking at arithmetic sequences. To start off, a sequence is just a list of numbers that are all in a very specific order. In other words, there's some kind of pattern that exists to get us from one of those values to the next value, okay? Each of the numbers in a sequence, we call that a term. So a term refers to each number in the sequence. And we'll use subscripts to refer to different terms. In other words, if I say something like a with a subscript of 1, I'm talking about the first term in the sequence. If I say something like a with a subscript of 12, I'm talking about the 12th term in the sequence, okay? And so as we kind of refer to these, we'll number the terms in terms of these values we call n. So n is like the number of terms that we're looking for, but then we'll label each term in terms of an a value, and we'll use a subscript to talk about which of those terms we're referring to, okay? And now specifically an arithmetic sequence is really just one of these sequences, but the pattern is that we're adding the same thing each time. So a sequence in which each consecutive term is found by adding a constant value to the previous term. Okay? And so when we're looking at this thing, a sequence is, hey, it's a pattern, all right? Each of the values in the sequence is called a term. And if the pattern happens to be adding to get from one term to the next, well, then we call that an arithmetic sequence. Okay? For example, if I look at these guys, just taking a look to determine, well, are these arithmetic sequences? And then from there, could we determine the pattern and continue this pattern and find the next couple values of the sequence? And so if I look at something like this first one, to go from 55 to 49 to 43, it looks like I'm subtracting 6 each time. And so the question is this arithmetic? Am I adding the same thing each time? And the answer is yes, I'm adding a negative 6 each time. And so this one is arithmetic. And it's arithmetic because I'm adding the same thing each time. It has to be a negative 6. I could keep this going and say, hey, the next term is a 37. After that, it's a 31. And then I could keep going from there. Okay? So we need to identify, all right, what's the pattern? Is it arithmetic? Am I adding the same thing each time? And then from there, could I keep the pattern going? Could I continue that pattern? If I look at the next one, to get from 8 to a 17 would be up 9 units. And then to get from 17 to a 26 would be up 9 units again. To get from a 26 to a 35 would be up 9 units again. So I'm adding 9 each time, which means this thing is arithmetic. So this one is arithmetic. I could find the next couple terms by simply continuing the pattern. Continue to add 9 each time. That's going to be a 44. Followed by 53, and of course that could keep going, all right? And now if I look at the next one, I go from 3 to 6 to 12 to 24. Again, just identify the pattern. The pattern this time is I'm multiplying by 2 each time. And so if I'm multiplying by 2 each time, it still has a pattern. The pattern still exists. I could even continue the pattern and say, hey, that's a 48 and a 96, and I could keep going from there, all right? But this is not the special pattern that we would call arithmetic in terms of the way the pattern exists. I'm not adding the same thing each time. I'm multiplying by the same thing. So this one is not arithmetic this time. Okay. In terms of finding different values in an arithmetic sequence, an arithmetic sequence is given by this equation, a sub n, so the nth term equals a sub 1, which is the first term, plus n minus 1 times d, okay? So the nth term equals the first term plus the number of the term we're looking for minus 1 times d. And when you look at this thing, you know, this equation might feel a little bit familiar. Maybe it doesn't as you look at this thing. But what if I were to subtract that a sub n, that a sub 1 from each side, and write it as a sub n minus a sub 1 equals n minus 1 times d. And if you look at that, hopefully that looks a little bit familiar. If it doesn't, let me rewrite this guy. Maybe I'll write the d times n minus 1. And if that still doesn't look familiar, maybe I'll replace the d with an m. Maybe I'll replace n with an x, okay? And so as I start to look at this thing, a sub n, maybe I'll replace with a y. And so when we look at this thing, this is the ordered pair. The first term is an ordered pair of 1 comma well, whatever the y value happens to be. Oh, instead of calling it a sub 1, maybe I'll call it y sub 1 here. What do you think? And maybe instead of calling this, a 1 for the x value, I'll just say whatever the first x value happens to be, okay? And so as we look at arithmetic sequences, hopefully you recognize right away that, well, if the pattern is adding the same thing each time, that's the pattern of a linear function, of a linear equation of y equals mx plus b, or in this case, y minus y sub 1 equals m times x minus x sub 1. When you look at the arithmetic sequence formula, it's really just point slope form, except I'm kind of locking myself into the first term, which means when you think about an arithmetic sequence, the first x value is always going to be a 1. And so I replaced that first x value with a 1. Okay? And then the first y value is whatever I get when I plug that 1 back in. Okay? And so that's the idea here. When you look at the pattern, when you look at the values of this thing, it's basically a linear function, except we're looking at it from the perspective of starting with the first term instead of like y equals mx plus b, which is when you would start with the 0th term, okay? And so as you think about that, yes, you can use this formula and know this formula and memorize this formula and remember that n is the number of the term, a sub 1 is the first term, d is the difference between the terms, that thing that we're adding each time. Or you could just convert this thing to a linear function, a linear equation, and then plug it in from there, okay? I'll show you kind of both ways to approach this, all right? If we're using the formulates here, again, some of the slight differences, again, a sub n is the term we're looking for, a sub 1 is the first term, n is the number of the term we're looking for, and then d, that stands for difference. It's the common difference. It's the thing that we're adding each time in terms of that pattern. Okay? For example, if you look at something like this guy, it says find the 40th term. And so as I look at this thing, you could think of it and just say, okay, well, right here, this is the first term, this is the second term, this is the third term. So in terms of labels, this would be like a sub 1, a sub 2, a sub 3. And of course, I want to work my way all the way out to a sub 40 and figure out what that guy is. Okay? And so in terms of numbering these terms, so if I plug this into the formula, I would just say, okay, a sub 40 is now the thing that I'm looking for. All right, I want the 40th term equals a sub 1, which is the 55, plus n minus 1. Well, n is the number of the term. I'm looking for the 40th term, so I use a 40 for the n value. And then times d. Well, d, I have to look at the pattern. The pattern here was adding a negative 6 each time. So that's what I'm going to multiply by in my formula. And now from here, this is really just a job for my calculator. I plug it in. I do the 40 minus the 1 is a 39 times the negative 6, and then plus the 55. And when I do that, I get a negative 179. So a sub 40 is a negative 179. Okay? The other option here is I could kind of look at it this way. Instead of writing this as a sub 1, a sub 2, a sub 3, let me think about this as like an XY chart. 1, 2, 3. So here's my XY chart, okay? And if I kind of looked at this from the perspective of an XY chart, this is the formula. Y equals, well, negative 6, the thing I'm adding each time, that's my slope. And then think about what the y-intercept would be if I continued the pattern back here to 0. Well, this would be a 61. So plus 61, okay? And now I want the 40th value. In other words, I want to keep going until I have an x value of 40 here. So let's go ahead and plug an x value of 40 in to this equation down here. So I plug a 40 into this guy, and I get y equals a negative 179, okay? And so I get the same thing either way, whether I think about it as a linear function, y equals mx plus b, or whether I think about it using that arithmetic sequence formula, okay? If I look at the next one, same kind of thing here. I can plug it right into the formula. I want the 22nd term, so a sub 22 equals a sub 1, which is the 8, it's the first term, plus n is 22. I'm looking for the 22nd term. And then the d value this time, I just look at the pattern and say, oh, I'm adding a 9 each time, so that's what I multiply down here, okay? And once again, this is a job for my calculator. I'm going to plug it right in. And I get a 197. Okay? If there's not enough space in our brains to memorize that formula, once again, I could think of it as, oh, this is the first term, the second term, the third term. Think of that, about that in terms of like an XY chart. Okay? And so I think about this in terms of an XY chart. Well, let's find the y-intercept. That's going to be 0. If I continue the pattern back the other way, that's a -1. So the equation in point and slope-intercept form is 9x minus 1. And so we're used to writing these linear equations. Well, let's apply it to this sequence, to this pattern, okay? And now from here, I want an x value essentially, if I keep going here, of 22. Well, let's plug the 22 in. So I do the 22 times the 9 and then minus the 1. And once again, I get a 197, okay? So it's really important to understand that, yes, these are still just linear equations, but we're applying linear equations to a specific context and we're thinking about them in a specific way, okay? We're not thinking about them in terms of x going to zeros and negatives and that kind of stuff. In this scenario, we start with like an x value of 1, or in this case, an n value of 1. I start with 1 and I work my way up from there. We're dealing with the positive realm, okay? And really, it's the same kind of thing. It's still just looking at a linear equation, but only looking at the positive values, okay? If I look at this guy, it says find a sub 31, so I want to find the 31st term. Once again, I could just start by plugging this guy right in. I want to find a sub 31 equals, well, a sub 1, the first term here is the 34, plus n minus 1, n is a 31 this time. And I know that because I'm looking for the 31st term, so n is the number of the term. It's the 31st term, I use a 31 for n. And then d, the thing I'm adding each time, is a 4. And so once again, this becomes a job for my calculator. So I plug it in and I get a 154. Likewise, if I decide to do this in terms of a linear equation, I would say, oh, well, this is the equation, y equals, well, let's say 4x. And then just think about going backwards in the pattern. If this is 1, 2, 3, if I keep the pattern going the other way, 0 would be paired up with a 30. And now once again, I could plug that 31 in here. If I do the 31 times 4 and then plus the 30, I still get that 154. Okay? If I look at the next one here, 55 is the blank term of the sequence that's here. And so this one, again, I got to kind of start with what I know here. And I know right away that a sub 1 is a 4, so I could plug that 4 in, plus n minus 1 times d. Well, d I can see, that's adding a 3 each time, so that's a 3. But now the thing it's looking for here is it wants to know what is that 55 is what term. In other words, what is the number of the term that 55 represents? So n is the thing that I'm looking for. And the term in question that I'm actually using is the 55. Okay? So this time 55 is the term that this equals, but I want to work backwards to solve for the number of that term. Okay? And so then once again from here, I can solve this thing. There are a couple different ways to solve. I would probably subtract the 4 from each side. And then divide by the 3. And I'll add that 1 to each side. I guess I don't need to write the plus 1 there. So it's the 18th term. Okay, so 55 is the 18th term of this sequence. Okay, you could also distribute that 3 and get a 3n minus 3, and then solve from there. That would be fine as well. It'll give you the same thing. But once again, we could take this from the perspective of, well, let's just think about it in terms of a linear equation. It's y equals, well, 3x, and then just think about what would the y-intercept be here. I'm looking at this as 1, 2, third term, so that means the 0th term. Well, that's going to be a 1. Okay? And now from here, instead of n, I'm solving for x. It's giving me the y value. It's essentially giving me the value out here of 55. And I want to know what x value goes with that. Okay? And so once again, I do the same kind of thing. I plug it in. I say 55 equals the 3x plus 1. I'm going to subtract that 1 from each side. divide by the 3, and get an x value of 18, which then I'd have to rewrite as, well, n equals 18. It's the 18th term, okay? For these guys, it says write an equation for each sequence. If we're going to go the approach of just looking at this as a linear equation, just make sure you use the arithmetic sequence variables for this thing. In other words, for this one, if I were to kind of just do the straight formula of a sub n equals a sub 1, which is a 4, plus n minus 1 times d, which is a 3, that is the formula, but I have to write this in simplest terms. If I distribute the 3, my formula ends up being a sub n equals 3n plus 1. And for anybody who's been paying attention, this is the same as the previous example. Well, here it is right here, 3x plus 1. All right, a sub n equals 3n plus 1. When we write this in simplest terms, we're literally writing the linear equation in slope-intercept form, but we just have to make sure we use the arithmetic values in terms of the variables, okay? Instead of y, use a sub n. Instead of x, use n. And that's it, all right? It's doing the same thing. If I look at the next one, same kind of thing. There are two approaches to this. I could look at it and say, okay, well, a sub n, let me separate this, a sub n equals a sub 1, which is a negative 1, plus n minus 1 times d. d this time is 4. I'm adding a 4 each time. And so now it's distribute, combine like terms. And again, if I just look at this as a linear equation, say, hey, this is the first term, second, third, fourth. Well, let's work our way backwards. So let's continue backwards and find the y-intercept. Well, it's negative 5 if I continue the pattern the other way. So that would be like the equation y equals 4x minus 5. And now I just convert it to the appropriate variables for arithmetic sequences. The last thing we're going to look at here is arithmetic means. Arithmetic means are basically like missing terms in an arithmetic sequence, okay? So terms between any non-consecutive terms in an arithmetic sequence. I basically have some gaps that I want to fill in, and really what this comes down to is looking at this thing from the perspective of, well, I have a sub 1, I have some other value that I know what the n value is, I know what the value of that thing is, and so what I have is all the pieces of the equation except for the d value. And the d value, the common difference, the thing that I'm adding each time is really what I need to fill in all of these blanks. See, if I have the d value, I can just add it on here to get from one term to the next term to the next term to the next term, okay? And so what I do is I just look at what I have. I say, well, I have a sub 1. I'm missing a sub 2. I'm missing a sub 3. I'm missing a sub 4. I'm missing this guy. But I have a sub 6, okay? And so when I think about that from the perspective of the equation, I have a sub 6, which is 19. So let's see, this is 16 plus n minus 1 times d. d is the thing that I want. And when you think about this, these are my two variables, a sub n and n. Well, I have a value for each of those. I could use these values right here. I could use the value of 19, which means I'm using an n value of 6 in my equation this time, okay? And so from there, this is just a matter of solving a simple linear equation. Okay, I simplify just a little bit. That gives me a 5d. And now I subtract that 16 from each side. And I divide by the 5. And yeah, this is going to be a decimal. No, it just ruins your day putting a decimal in here, okay? 0.6. But now the question didn't ask me for d. d was a necessary part of this thing. That's what I need to get from one term to the next. And so I just added on there. 16 plus the 0.6 is a 16.6. Plus 0.6 is a 17.2. Plus 0.6 is a 17.8. Plus 0.6 is an 18.4. And then do it one more time. Instant check, plus 0.6, it gives me the 19. If I don't get the 19, well, I made a mistake in here somewhere. I got to go back and fix it. And so here's my arithmetic means. Those are the missing values that I was looking for. And once again, you could do the same thing in terms of setting up an XY chart and just call these by their X value names. Well, now when I write the equation, I just have y equals mx plus b. I'm solving for m now instead, all right, so that I can fill in these gaps. It's the same thing, okay? If I look at this guy, same kind of thing. What I have here, this is a sub 1, a sub 2, a sub 3, a sub 4. This is a sub 5 for this one. And really, those are the pieces I need to identify. From here, I just plug it in. I say, you know what? If I use this 110, that means I'm using an n value of 5. I already know what a sub 1 is, so now I can find d, okay? And so once again, from here, I just simplify this guy a little bit and then solve. Subtract that 10 from each side. And divide by that 4. And again, the question didn't ask for d, but I just need d. I use d to get from one term to the next. If I add that 25, it gives me the next term. Okay? And then if I add that 25 again, it gives me the next term. And then if I add that 25 again, it gives me the next term. And if I add that 25 one more time, just make sure it gives me the last term. It gives me that 110 like I'm supposed to have. These are my arithmetic means. Those are the missing pieces I was looking for, okay? So arithmetic sequences, the pattern is that I'm adding the same thing each time. I have a special formula for this thing that kind of looks like and really just is point slope form. But I can always think of these as linear equations. I can always think of them as y equals mx plus b if that is easier, okay?